So this is the physical science lesson video for section 14.3. And as always, if you want all my videos in one spot, just subscribe to my channel. So we're going to talk about mechanical advantage and efficiency in this section. So the mechanical advantage of a machine is the number of times that the machine increases the input force. So a lot of times we need a machine to increase the amount of force we put in because we can't provide that force ourselves, so we need the help from the machine. So the actual mechanical advantage, which is abbreviated AMA, is the ratio of the output force to the input force. So remember, anything that starts with output is done by the machine. Anything that starts with input is done by us on the machine. Alright, so it's output force over input force. The ideal mechanical advantage, or IMA, so that was actual on the previous slide, of a machine is the mechanical advantage in the absence of friction. Because remember, we talked about how you can never get as much work out of a machine as you put in due to the machine having to overcome friction. Because friction is always present, the actual mechanical advantage is always less than the ideal. Just think about it. Things that are ideal don't actually exist. So reality or actual things are always going to be less than the ideal. Okay, so we can't ever meet the perfect situation with no friction. So the ideal mechanical advantage, which is abbreviated IMA, is the ratio of the input distance to the output distance. So whereas actual mechanical advantage deals with the forces, the ideal mechanical advantage deals with the distances. And remember, this is the one where there's the absence of friction. So your actual will always be less than your ideal. So let's look at an example. So it says a woman drives a car up a ramp that is 1.8 meters long. The ramp lifts the car to a height of 0.3 meters. What is the IMA? Alright, so it says a woman drives a car up a ramp that is 1.8 meters long. That means this is how far the woman has to drive. So this is our distance, but it's our input distance. I call it D sub I instead of writing the full thing out, input distance. So it's D sub I. The ramp lifts the car 0.3 meters. So that's the distance that the ramp did. So that's our distance sub O, which would be our output distance. Alright, so our formula for IMA is our input distance over our output distance. So I just plug in. So my input distance is 1.8 meters. That's how far the lady traveled. My output distance is 0.3 meters. That's how high the ramp lifted the car. So when you do 1.8 divided by 0.3, you get 6. Now let's look at these units. Meters and meters will cancel. So mechanical advantage has no units. Alright, no units on mechanical advantage. Whoop, oh. Alright, so let's look at a couple more. So as always, pause the video, try these on your own, and then check your answer with me. So it says a construction worker moves a crowbar through a distance of 0.5 meters. So this is what the construction worker did. So this is my distance input. To lift a load 0.05 meters off of the ground. So in other words, the worker moved this much, the crowbar moved this much. So this is my output distance. What is the IMA, or the ideal mechanical advantage? So remember, IMA is your input distance over your output distance. So what the input distance is 0.5 meters. The output distance is 0.05 meters. So when you divide, you're going to get 10. Those meters cancel, so you have an ideal mechanical advantage of 10. And the higher the mechanical advantage, the better the machine is. So number 3, we got to do a little bit of rearranging. So pause it, try it, and then let's look at it together. So it says the IMA of a simple machine is 2.5. So they gave me the ideal mechanical advantage. If the output distance of the machine is 1 meter, so they gave me my output distance, what is the input distance? So this time we're actually looking for input distance. So remember what I told you, we got to be able to rearrange formulas. They're not always going to make you solve for the same thing. So we have IMA equals my input distance over my output distance. If I want to solve for input distance, I need it to be by itself. So I've got to get output distance on the other side. So to do that, we do the opposite mathematically. So right now, we're dividing by output distance. So what's the opposite of dividing? Multiplying. So I multiply both sides, because remember, in an equation, if you do something to one side, you have to do it to the other. I multiply both sides by output distance, so they cancel on this side. And so I'm left with my input distance equals my output distance times my ideal mechanical advantage. And once I have that, I can just plug in. So my output distance is 1 meter. And my ideal mechanical advantage is 2.5. So there's some easy math. 2.5 times 1 is 2.5. And then let's look at our units. Well, ideal mechanical advantage has no units, so I have a meter. So my input distance is 2.5 meters. All right, so hopefully you got those right on your own. So next we're going to talk about efficiency. So we did actual mechanical advantage, ideal mechanical advantage, and then there's efficiency. So some of your output force is lost due to friction. Okay, we've discussed that. So the percentage of work input that becomes work output is called the efficiency of the machine. No machine has 100% efficiency because of friction. Okay, so remember, that's why actual mechanical advantage is less than ideal. So actual mechanical advantage deals with forces, ideal mechanical advantage deals with distances, and efficiency deals with your work input and output. So here's the formula. Efficiency is your work output over your work input times 100. Remember, output's by the machine, input is by us on the machine. If you can reduce friction, that will increase the efficiency of a machine. So that's why a lot of times you'll see people, they use oil on gears to reduce the friction and things like that. So, section assessment. Why is the actual mechanical advantage of a machine always less than its ideal mechanical advantage? Well, remember, ideal mechanical advantage is the mechanical advantage in the absence of friction. In reality, friction always reduces the mechanical advantage. Okay, so you can say actual mechanical advantage includes friction, which reduces the number from the ideal mechanical advantage. All right, number 2, why can no machine be 100% efficient? Because of friction. Okay, we're always going to have friction that machine has to overcome. Number 3, what information would you use to calculate the efficiency of the machine? Well, we just looked at the formula. So efficiency, we need work output and we need work input. That's what we need. All right, because efficiency, of course, is our work output over our work input times 100. Okay, so you need work output and work input. So number 4, it says, what is the actual mechanical advantage of a machine that exerts 5 newtons? So this is what the machine does, and this is a force. So this is our output force for each 1 newton of force you exert on the machine. So that's my input force. Again, I use FO and FI to be output force and input force. All right. So this time we're doing actual mechanical advantage. So my actual mechanical advantage is my output force over my input force. So then I just plug in. So we have 5 newtons over 1 newton. So 5 divided by 1 is, of course, 5. Newtons will cancel because mechanical advantage, again, is a unitless number, so no units. All right, so let's move on. I think there's a couple more on the next slide. So again, maybe pause the video, try these on your own, and then check back with me and see if you got them right. So it says, you have just designed a machine that uses 1,000 joules of work from a motor for every 800 joules of useful work the machine supplies. Okay, so it says the machine has to use this. So this is our work input, and the machine actually does 800 joules of useful work. So this is our work output. What is the efficiency of your machine? Well, efficiency, I'm just going to call it E, is work output over work input times 100. So then we just plug in. So my work output is 800 joules. My work input is 1,000 joules times 100%. So those joules cancel. And so when I do 800 divided by 1,000 times 100, I ended up getting 80. And then because my joules cancel, I'm left with percent. So our machine is 80% efficient. 80% efficient. All right, so again, try number 6. You are going to have to rearrange it, but you need practice rearranging, and then we'll look at it together. So it says if a machine has an efficiency, so they gave me the efficiency of 40%, and you do 1,000 joules of work on the machine, so that's my work input, what will the work output of the machine be? So this time we're actually looking for work output instead of efficiency. So again, I'll say it one more time. You've got to be able to rearrange formula. So we have efficiency is work output over work input times 100. So we want to solve for work output. So I need to rearrange my formula. That means I need to get the 100 and the work input on the other side. So I do the opposite mathematically. So right now we're multiplying by 100. So what's the opposite? Divide. So I take both sides and divide them by 100. Okay, so those hundreds cancel out right here. All right, to make it easier for you to visually see, I'm going to erase them. So they have canceled on this side. Now I've got to get work input on the other side. Well, right now we're dividing by it, so the opposite of that is multiplying. So I multiply both sides by work input. So then they cancel. So what I'm left with is work output is work input times efficiency over 100%. All right, so then I just plug in. So we have work input of 1,000 joules. We have an efficiency of 40%, which is not very good, over our 100%. And so if you look, our percentages cancel, the 40% and the 100%. So we do 1,000 times 40 divided by 100, which is 400. And then the unit that we're left with is joules. Okay, so even though mechanical advantage doesn't have units, your work, your force, your distance, efficiency, those all do have units. All right, so let me make sure that's the last slide because I think it is. Oh, okay, it was. All right, so hopefully now you understand ideal mechanical advantage, actual mechanical advantage, and efficiency.